So, good evening, everyone. Welcome to the first technical session at OTX, and thank you for being here after a long day. Let me introduce myself. My name is Mohammad Abou Assali. I am a technical specialist for infrastructure based in the Dubai office and covering the Middle East and Africa. Okay. Today's session is about rail. I was very intrigued to get to know more about rail. So I've come up with this title, From Planning and Concept to Detailed Design. And I've noticed later on, once I was preparing for the presentation, it's a lengthy process. It's like too many details involved in the design and the construction of rail. So what you will see today in my presentation is like 40–50% of the whole workflow. However, once you log into the Autodesk Drive or whatever source you have access to, you will have access to over 110 slides covering the whole workflow with all of the videos, links, and everything you need to demo or showcase the workflow to your clients. Okay, so this is a brief introduction. Let me kickstart the presentation. First of all, you know about the safe harbor statement. If we show anything that's related to new features or things that we promise for the future, please don't share it outside with your customers unless they're already there in the market in the release itself. And the agenda for the session, as you can see, it's packed. So introduction, why rail? Why are we talking about rail now? The current situation, what type of problems our customers face. Generally, I'm not going to go into details. I'm going to cover very quickly the industry terminology. So for those of you who have never worked on rail projects, like myself, for instance, before, I've learned some terms that you might find useful for your presentations and customer demos. And then we move into the crux or the butter of the presentation, which is basically about the rail project's workflow. And here we highlight the Autodesk Solutions map. How do our solutions cover the whole life cycle of the rail project? So we talk about project planning, conceptual design, detailed design, design coordination and review. Finally, project experience, very, very quickly, although you have all the material in my presentation, which you have the freedom to look and share later on. And finally, the project documents management, which is basically going to be covered in the session, which is tomorrow or after tomorrow by P.Eng. Finally, a very quick bonus. Those of you who attended my session last year know that I usually like to have some bonus at the very end, so stick around. Okay, so why rail? Any idea? As you can see from this slide, and based on the latest studies about infrastructure, there is huge investments going into rail. So if you look into, for instance, the investments that are done in Europe, you can see the numbers, right? We have big investment in Europe, definitely, and in the rail network. I'm going to share with you another source showing the upcoming projects. And you can see the direct increase in what we call passengers kilometer. This is the metric which we use to capture how the passengers or people are using the rail overall. So this is a study showing the history in 2005, 2015, and 2025. So you can see the rapid increase in the rail passenger as well as the urban rail. Definitely the biggest investors in rail currently are India and China, and you know about the upcoming projects of China worldwide regarding to rail. So this is very quickly about the investments. These are just some snapshots and some resources online that you are free to check later on. This is regarding the Europe network of rails, the upcoming projects, when some projects will be delivered, etc., etc. There's the same one for the Middle East. Since I'm based in Dubai, there was a very huge project to connect most of the Gulf Cooperation Council countries. Unfortunately, due to the decrease in oil prices and the current situation, this project has been put on hold. However, we do have major projects running in Dubai and Abu Dhabi and United Arab Emirates. We have the major and well-known project of Qatar Rail, and definitely some other major projects in Saudi Arabia. So if you want to have an idea about the amount of investment going into rail recently, you can see, for example, UAE estimated about $27 billion. Qatar alone, 46. We have Saudi Arabia, huge investments into infrastructure, about 118. And definitely we have in other African nations. So this is very quickly the current situation and the upcoming projects. Now, also in terms of transportation, I think you've already heard about the Hyperloop. So this is a new project in UAE. This is a pilot project. basically connecting the major two cities in United Arab Emirates. It's Abu Dhabi, the capital, and Dubai. And this is a very optimistic project because basically allows passengers to go through a tunnel, enclosed tunnel at the speed of airplanes. So as if you're flying in air, but basically going in a tube very quickly. This optimizes the time of the trip, the cost of the trip, and definitely is very safe, as you can see. So it's contained environment that basically pushes you through that tube in comfort. So this video is for you to check later on, and cuts down the cost and time of moving from one place to another by like 1/10. So it's like 10 times faster. Okay. Why now? Because Autodesk is heavily also investing in rail. So we have teams that are dedicated to develop tools and features on top of InfraWorks and Civil 3D, and you're gonna see those new features this year specifically. And there are basic or major BIM mandates that are being rolled. So I was told about the Deutsche Bahn standards for the 2020 and the SNCF also for the 2020. I guess SNCF is the national operation entity in France, right? So we have in Germany and we have in France and we have others upcoming in the Middle East. So for Qatar Rail projects, which we as Autodesk were heavily involved, we also helped them put together the BIM guidelines for the Qatar Rail project. So already done, we have some implementation in Civil 3D about the rail cant, as you already know, for those of you who have the 2018.2 release. And we have other developments and new features coming this year. So this is from the I would say the macro picture of investments and the micro picture within Autodesk. So what is the current situation, problem, and solution? This is just a small, I would say, sales-oriented slide highlighting, for example, the situation. We have increased rail projects. We have focused on rail owners specifically because usually those who are the ones that drive BIM adoption. And we have the need to integrate both horizontal and vertical solutions. So usually, the design of the rail tracks is in one silo and the design of the rail station is in another silo. So how can we bridge the gap between the two? And this is the major differentiator between Autodesk and other solutions vendors. And definitely we have many, many solutions which you can find online and you can see success stories about them. I will not talk about this. I will move directly into these are some questions which you can check later. And I'll move directly into the rail terminology. I will not spend a lot of time because some of you already know it. Just to understand, whenever we talk about the rail track, this is the ballast or the ballast material, basically the bed that supports the rail. This is the rail, and these are the sleepers. And this is just to highlight that this is the gauge width, so it's from the sleeper to the sleeper, etc., just from the rail to the rail. So very quickly, this is another talking about what is cant. If you see me talk about cant in this presentation, basically it's super elevation for rail. So same like we have super elevation for roads, we have cant for rails. Now, what's important is switches and crossings. These are the ones where two track lines basically intersect or cross, and there are many different types of them, depending on many parameters. The speed of that line, how many, I would say the space, and if whatever. So there are many different parameters which basically detect what type of switch. This is the switch, as you can see, and moving the switch back and forth or sideways allows the rail whatever cabin to move from one line to the other. And this is the switch, and this is the crossing. So you might have two or more crossings at once. And finally, very quickly, once we talk about rail, there are three major rail types. We talk about high-speed rail. These are the rails that go around 300 kilometers or above. We have the light-speed rail. These usually go on lower speeds, so anything that's less than 300 kilometers per hour, we categorize it as light rail. And these usually have very frequent stops. So it's usually a short distance and frequent stops. And finally, freight rail for carrying goods and objects, heavy objects. So all of these are available for you to check later on with links. And now we go into the rail projects workflow. So what you will see online or anywhere is basically kind of disconnected solutions. So definitely you know about InfraWorks, definitely you know about Autodesk Civil 3D, and this is actually a 3ds Max rendering of a Civil 3D object. We have Revit for stations, and we have BIM 360, and as you know, we also have the capability to integrate parametric models from Inventor and InfraWorks and AutoCAD. So this is we all know about. What I've put together for this presentation and that you can use later on is kind of putting it in a workflow. So first of all, when we talk about project planning, the major tools that we use are Recap to get the existing conditions in point clouds. We have InfraWorks, and sometimes we do use Civil 3D. Now, these are the basic capabilities. I'm not going to read them all because there are too many, but I will show it to you in the upcoming slides. So we move from project planning to conceptual design. This is the typical workflow, but things can happen differently over there. And then from conceptual design, we move into detailed design. And here where we talk about Civil 3D for the rail tracks and Revit for the rail stations. Definitely we can go up with robot for the structure analysis. And once we are done with the detailed design, we can go into design review. And this is where we leverage tools like BIM 360, especially with the latest, the second generation of BIM 360 and the new upcoming modules. And Navisworks Manage if you want to have something that's meant for clash detection and simulation. We're done from design review. We move into project experience. We leverage InfraWorks again because it has very visual, compelling tools and it's easy to use. And definitely 3ds Max or /3ds Max Interactive if you want to go one step further into virtual reality or even using the Oculus Rift or the other one, HTC Vive. Okay, so this is basically the workflow. And finally, once we move into construction, we can talk about BIM 360 docs. There are specific modules that cater for construction. So this is basically the workflow. These are the points that usually our customers will raise or will flag or will ask us questions about. Most of them are covered in my presentations, not all, but if there's anything missing, this is I consider work in progress, and I'm gonna update it later on, okay? So let's start with project planning, very quickly. InfraWorks is the right tool for project planning. Why? Because of the following reasons. We can build huge models, right, that can go up to thousands of square kilometers. We can leverage Model Builder, which reads from free data online. And recently, or not recently, I would say soon, we will have integration with GIS, the database coming from Esri. So we will have more insight. It's a basic and very powerful data aggregator. So here, as you can see, we have terrain that's coming maybe from civil. We have satellite imagery, raster image. We have a Revit model or 3ds Max model, and city furniture all put together in one single platform, okay? We can create multiple design options, do quantity takeoffs, and definitely integrate with the detailed design tools. So from within InfraWorks, we can push, for example, the rail tracks into Civil 3D, and I'm going to show you how, the different methods and techniques. And we can leverage also, if we have any bridge for a rail track, to push it into Revit for detailed modeling. So let's talk about existing conditions. This is a tool that I've come across recently. It's basically from Leica, okay? And this tool has a very defined purpose, is capturing the existing rail track very accurately and depending on certain parameters. The accuracy of this device is up to 0.3 millimeter. It captures the rail, the sleepers, the ballast, and everything around them. This is very useful for the maintenance, servicing, and even for the upgrade of the rail track. Now, we get this data that's coming from the scanner that's on top of this device in terms of RCM or point cloud, whatever the file format, and we push it into Recap 360, the well-known platform for point cloud processing. That point cloud gets pushed into Civil 3D or also can be leveraged in InfraWorks, as you can see in here. So this is just showcasing some of the basic formats that we can read or write to. We get the existing conditions. We can leverage it with other sources in InfraWorks. Some of the slides you will see me going quickly because I have a lot to cover, but if you have any questions, we'll take them at the very end. Now, this point cloud can be used in a smart way inside of InfraWorks. We can leverage it. So what you see here, these are two webcasts available online from the product development team, showcasing how we can take, for example, or analyze and detect linear objects. That could be a track, that could be the edge of curb, that could be road marking, whatever the case is, and push this data into Civil 3D for further design. Or also, if we have certain objects like trees or light posts, also detect them automatically and replace them with 3D objects from within the InfraWorks library. If you want to know more about these, you can go to these webcasts and watch them online. Each one of these is 1 hour long. So we have the existing conditions. We leverage them in InfraWorks. Another case study from AEC regarding the stations and how AECOM was able to leverage it here. And definitely push that data in multiple file formats from the point cloud to Civil 3D. This is a video from my colleague Frederick, who's going to showcase it to you, I think, tomorrow or after tomorrow. Yeah. So this is just a teaser, I would say. It's relevant to rail, as you can see, existing rail probably, and detecting those lines and checking them in the cross-section view in InfraWorks. Then you can specify as a break line, as an edge, or whatever, and then use it in your design process. And then we have what we call the feasibility study. This is a basic tool within InfraWorks, very similar to GIS commands or functionalities, where you can, for example, set certain areas of interest, specify the weight, and then the software will create a heat map where you can leverage and use to know where you want to, for example, create your own rail track, or where you want to place your stations. Sorry. So this is from the GIS part and the planning part. We also able in InfraWorks, and this is why it's a very powerful platform, because it reads both 3D, BIM data, and 2D. So for the planners, we can bring in base maps like zoning areas, cadastral maps, or even 2D DWG. It doesn't have to have any elevation to it. And this all also helps in the planning process throughout. So once we're done with the planning, we move into conceptual design. So now we have all of our existing conditions, all of our requirements. We're able to put some concept in place. So let's start with the rail tracks. If you want to start a rail track conceptual design in InfraWorks, you can use the planning rail tracks, which is from here, the 10th item from the top. And then you can use the built-in styles for on-ground, above-ground, and underground to create those rail tracks. Now, this way is very, I would say, limited, because you only have like gizmos and vertices, which you can add vertices, remove vertices, lift them up and down to change the profile, but you don't have any feedback about the slope and the elevation or whatsoever. So we can't leverage the profile viewer. Now, the other thing about this, it's very good for conceptual, but it's not as powerful as the other tools that I will show to you later on. So this is the first step of having a planning rail track. Now, if you use that tool, the only, I would say, beneficial or power thing is that once you have an angle between two rail tracks that's less than 40, it will create the crossing. Remember the video I showed you with the crossing and the switch? It will create it automatically for you. And if you have, let's say, 2 by 2 or 1 by 1 or 3 by 3, it will also create the crossings for you. But if you try to cross, for example, one rail track with 2, it will not do it for you. So there are certain limitations and certain powers to it. The other thing that's actually limiting the power of that tool is that because it has a default style in InfraWorks, and if you're using, for example, the bridge style for the rail track, you will have one pillar or column supporting the bridge, but you don't have any input or power to change the location of that column, unless you make use of something we call creating a zone. So you basically split this zone and split another zone, and then you will have the capability of having the pier here, and then you will have another one here. If you're not satisfied, you can use the combine feature to connect them back again. So certain positives and negatives over there. Another thing that's very powerful also for the planning of rail tracks, the basic ones, is that we have specific style editor. So inside of the style editor, you can specify whether it's rectangular or box, tunnel, or it's circular. And you have here, for example, material and the different terms for the rail, the width, the gauge, the sleepers, the flange, etc. So this is another powerful thing about this tool. Now, what if we're done with the conceptual track and InfraWorks using this planning simple tool, and we want to move it into Civil 3D? For those of you who move models back and forth between InfraWorks and Civil, you will notice even if you tick everything in Civil, there is nothing called as planning rail track, right? Can somebody see rail track over there? No? You can't get a planning rail track into Civil. So even if you tick them all, what you will end up with in civil is basically you can bring in the terrain, you can bring in any design roads, but you will have nothing listed there in Civil 3D as a rail track. So this is the limitation from pushing planning rail tracks into detailed design. It's good for that purpose, conceptual, or early on, but not for detailed design. So what if we want to move that rail track into Civil 3D for detailed design? So as you can see, once we hit the right-click feature in InfraWorks, very limited features or capabilities inside of InfraWorks. Whereas, if we're using, for those of you who used design roads, once you right-click on any design road, whether in plan or profile, you're going to have different features, much more than the planning, and you will have this capability of converting the planning road into a design road. Okay? Design roads, as you know, will come nicely into Civil 3D as a profile, as an alignment and profile. So the solution would be, if we want to leverage, right, the planning tools in InfraWorks, is by having a style for design roads. Because if you go in InfraWorks now, you won't find a style for design roads that look similar to rail tracks. So what I've provided with my folder with the presentation is basically a JSON file that has two built-in styles for rail track, and they will work with design roads. So this is which you can leverage in your presentations later. So what I'm doing here, I imported this JSON file into the catalog, and then I'm using this rail style inside of design roads to sketch or design my rail tracks inside of InfraWorks. This gives me a lot of flexibility about how to do the crossings. As you can see here, we don't have this smart crossing between the rail track and the road because it's design road, but still we can change many things within the platform. We can check the profile and the profile viewer, etc., etc. We can leverage definitely the bridge module, because here it's a design road. So we like kind of roll the carpet from station A to station B. We have the bridge, and then we do some minor modifications in there to make it look perfect. Here we have the full power to locate the pier or the column, depending on the station. And by just using those styles that I've provided for you, you can change that into a bridge rail track very easily. So leveraging the power of road, design roads in a rail track context. Okay, so we've done two things. We've sketched planning rail tracks. We've used the design roads using rail styles. Now let's move into 3D polyline rail track alignments. If you have a customer who has rail tracks alignments that's done in any other software, could it be anything? We can still read it inside of Civil 3D, and from within Civil, we can export using the max export functionality into SDF, a spatial data file well-known in Autodesk, and shapefile for GIS. We highly recommend SDF because it takes multiple objects, not just one. But that's just a technicality. So we push that export from Civil 3D into InfraWorks, and we use it for our design. So this is the 3D polyline inside of Civil. You will have vertices, maybe it depends, every 5, 10, 20 meters. And then using the max export, we export it into SDF very quickly. We specify the coordinate system for it to be exported correctly into InfraWorks and placed in its right location. And once we're done with the export, we just go to InfraWorks, to the data sources, and we import it like any other data source. Very, very minor configuration requirements. We just have to set it as a rail track, and then we can assign a rail style to it from the library. We don't have to drape it because remember, it's a 3D polyline, so it has elevation in it. Just don't drape it, and then it will come nicely inside of our InfraWorks model. Okay, so this is the 3D polyline into InfraWorks workflow. Now, there are definitely certain limitations to it because, again, we're not working with design roads or component roads, but still serves the purpose, bringing that 3D alignment into InfraWorks. And then you can basically create zones, modify the style inside of the style editor as we've seen in the previous slides. Okay, so this is 3. What if I do have a Civil 3D rail track alignment that I want to push into InfraWorks, right? So this is number 4. I just have to remind you that here we're using the native Civil 3D drawing or model opened in InfraWorks. into InfraWorks, and then we can leverage the other tools that I will talk about in a second. And when I say a civil 3D alignment, I don't mean a civil 3D rail track, because unfortunately, up to date, the civil 3D rail track is taken as a planning road in InfraWorks. So what I mean here is basically a road alignment, right, which we've designed as a rail track, and then we save it. I'm just here saving it. Let me just save on time. We import, or we actually link to the civil 3D model inside of InfraWorks. Depending on the different objects within the civil model, it will take time to read it all. Once it's read, you will have the option to select, for example, the surface or the rail, the track or whatever. Here we're just selecting the track. And then also no need to drape it because it has 3D elevation. Just maybe change the style if need be, hit OK, and these are the styles which I provided for you. This is for the design roads. And then InfraWorks will read that track into the model. So what you will have now is not a planning road, is not a 3D polygon, it's a design road with all of the intelligence of design roads. By that I mean we can, for example, move it into component roads, we can create zones, and set different styles for different zones across the way. We can have, for example, as you can see, a tunnel. We can change the parameters of that tunnel, etc., etc. So this is these are some of the capabilities or powers of design roads. Definitely adding grading, optimizing the quantities, etc. So for you to create any new style other than the ones I provided for you, you can use the style editor in InfraWorks, and this is the basic one for design roads. And using this button over here for decorations, if you have any object that's, for example, a 3D object that's FBX, you can leverage it inside of InfraWorks and here place it horizontally or vertically and specify the spacing in between. Or else also you can leverage the custom profiler. So if you have a certain profile in DWG, you can use it along the way, like a guardrail or handrail or whatever. Also, I provided the session, so this link over here explains all that and much more for those of you who are interested to create their own styles. The second way of doing it is basically by making use of the materials in InfraWorks. So having the material as textures, as raster files, JPEG or PNG or whatever, saving them in the InfraWorks library. Don't worry, it's too much, but the session is over here, so if you wanna, and then using it just as a texture on top of the surface. So it will be very light, very simple, but still will look visually compelling and good for the eyes. So these are two ways of creating those styles. Okay, what about component roads? So we discussed 3D polyline, sketching and planning roads, moving from civil to InfraWorks. What about component roads? As you already know, component roads are the highest intelligent roads within InfraWorks, and most of the development is going into them. So here we do the same trick. We use the same Civil 3D native model into InfraWorks, and we leverage it as component roads for earthwork optimization, profile and corridor optimization. We have detailed quantity takeoff, which I will show later. We can leverage watershed analysis, the total volume calculation, and in the near future, we're going to have a Civil 3D corridor from the component roads. So this is just an example. So here we have a rail track. It could be the same one that we've got from Civil 3D as a design road, basically, and configure it with rail style. We can just right-click and hit convert into component road. The process can be either manual or automatic. And then from within the sub-assembly, I would say library for the component roads, you can make changes to each and every part of the track, right side, left-hand side, median, etc. So very flexible tool for modifying. As you can see here, we can specify from one station to another station. And those of you who know component roads know how flexible that tool is. And if we are done with a certain profile or certain type of assembly, we can easily save it as a sub-assembly and use it in our future projects. We can leverage the design tools or design visualization tools like the cross-section, show it differently, see where is the cut, where is the fill, etc., etc. And this is just a quick video, which I will not run it through it all. This is actually, I would like to thank Frederick So I've taken his video in German and I've done it just in English. So if you have a component that's in 3D, let's say DWG in AutoCAD, you can export it as FBX file. This FBX file, because remember, we're talking about component roads, and we might not have all the components available in the InfraWorks library. So here I'm saving it as an FBX inside of InfraWorks. I'm just creating a basic component style for rail tracks. All this process is detailed. I'm going to show you the steps later. So you create, for example, a lane, you put the shoulders, you put the slopes, etc. Once you're done, you can save that as a sub-assembly. I've saved the base, and then I'm importing that 3D model of the sleeper or the rail into the catalog, saving it, and then I'm using it inside of this assembly. I'm rotating, etc. Then I'm hitting the tilting button, and then I'm saving the whole thing as one sub-assembly for my later use. So this workflow, which I'm showing here. So if I go into the presenter mode, and this is what I want you to do later, you will find all the steps in detail available here. And most of my videos, I've put the text in there step by step. So you don't have to have the voiceover. You can learn that on your own. Okay. So we're done with that. Once we're using the component roads, we have to leverage the capabilities, right? So what about the analysis? Once we have that road, it's very easy. We click on that road. We go into the bottom of the asset card. We hit on the calculator button, then again, and everything that's basically building that rail track will pop up. The nice thing is it's also taking into account the components. Remember the one we've exported earlier as FBX? It's also taken into account. So everything that's added will be shown in the material takeoff, which you can export as a CSV file to be used for estimation later. So even for those owners, operators, or planners who are doing the conceptual design, they can have a feel about what is the cost of the project early on by taking the material quantities, multiplying with the unit cost, and they get an idea about the total cost. And again, another thing that they can leverage basically for rail tracks, especially here in Europe, is checking for the watershed analysis. There are many parameters and features over there. Basically, it's a cloud service that takes a copy of the model to the cloud after selecting the alignment, and then analyzes where is the water going to clash or intersect with the alignment. So it will highlight the watersheds, as you can see here, in different coverages. These are coverages which we can manage. And these are the water streams where the water will collect. And the points where the water will hit or intersect with the with the rail track, there will be a point of interest. Now, each and every coverage might have a different permeability parameter or runoff coefficient. So we have the power as, for example, hydraulic engineers to input these in and then run the analysis again. Even if we have rainfall data, we can bring in the rainfall data for the 10-year, 25-year, 50-year flood, etc., and then run the analysis in order to check for the flow and design the culverts that are crossing that rail track. So if I move further on, you will see that the software is automatically creating a culvert. It's giving us an idea about the hydraulic performance of that culvert, flow before and after, etc., etc. So we're moving from just sketching something, planning something, into designing and checking for performance. And this, again, is available for the design and component roads, not for the planning. Again, I would like to thank my colleague, Frederick. So those who are in charge of planning a rail track, they would like to know what is the land usage. So this video of his showcases a workflow between InfraWorks and Civil 3D, basically leveraging the sketching capabilities of InfraWorks and Civil 3D as a GIS tool to bring this data into Civil 3D, do some overlay after importing all the GIS layers, and checking for the usage of the areas. So here we're doing the overlay of these features. And again, you will find all the steps underneath the slide itself. And then you can import those. This is what I like about it. He brought the land that has been used as for the right-of-way into InfraWorks. And these are separate coverages for separate steps of the project, which we can leverage for costing or for checking of any problems on site. Then we move into detailed design. Now this process is lengthy, so we have two, I would say, tracks here. We have the one that's for the stations, and we have one that is for the tracks. The ones for the stations, it's well known worldwide that our customers are using Revit. Unfortunately, I was not able to get you the models I have from our customers because I'm from the Middle East, and customers over there are very, very protective. I have magnificent models, but I can't share them. So what I will share with you is the Deutsche Bahn, sorry, case, which is over there on this link. There is a long manual actually of steps and things that are done for Deutsche Bahn. And there is also in the folder which you have access to a simple yet BIM model of a rail station. The problem with it, though, it's all in German. So even if you check the schedules and Revit, you will have it all in German. So unless you understand German, you won't be able to understand what type of material. So this is what you will have access to. And then we have the rail tracks themselves. So once we sketch or we plan those tracks in InfraWorks, and highly likely we should do them either using design roads or component roads, as I showed you, we can bring them across into Civil 3D. Now, this part will take at least half an hour, so I'm not going to bother you with these. I'm just going to tell you that in 2019, we're promised to have canned rail support in the sub-assembly composer much, much better. And earlier this year, we had the turnouts and crossovers supported as of 2018.2. Honestly, I don't have access to this, so I don't know if this will come, but just to give you an idea and keep you in the picture. So here, again, back to this schema diagram. We have the rail tracks in InfraWorks. We can use them inside of Civil, and inside of Civil, it's very easy. We can open either an exported instance IMX, because if we export as IMX, it's just a copy of the model. It has no direct link to it. Or we have a direct link to the SQLite InfraWorks model inside of Civil. Any changes in InfraWorks will be shown in Civil. Any changes in Civil will be shown in InfraWorks with just a single refresh button. So this is the workflow that exists. So this is regarding the Cant and sub-assemblies. Hopefully we're going to have it in 2019.0. And then you will find, once you go throughout the presentation, you will find that there are many videos detailed. Each one of them is about a certain topic. So you will have about 4 minutes on alignment design inside of Autodesk Civil 3D. How to use the rail alignment tools inside of Civil. Another one is about Cant calculation. By the way, all of these videos were created by my colleague Peter Engels, so it's not my work, it's his work, just to clarify things. Then about the embankment modeling and how to calculate quantities of cut and fill, and earthworks quantification. So these will take you about 20 minutes, but they're very slow and very easy to check. And then we have the horizontal and vertical, bringing them together. I will skip this video to cover the other ones. Let's move into coordination and review. So we're done with the planning, we're done with the conceptual, the detailed design, then the coordination and review. Early on, we used to have the power of pushing models from InfraWorks to the cloud, showing them in web browser. So it's supported today, but as I was told, it will be phased out this year. So don't actually talk to customers about it. And the other thing, sorry, this one is about the pushing the model to the cloud and then showing it on the iPad app. So it will not be supported anymore. This is the first one. The second one is pushing it to the web viewer, which was kind of limited in terms of power. And this one also will be phased out early this year. So just to put you in the picture. What you can tell customers about is basically they can share models in the cloud. They can add participants or team members, and they can give them access rights. Depending on the access right they will have certain privileges or not. So this is for sharing. The other thing which is still in beta or testing, we used to have it last year in Sandbox, and now it's also in Sandbox with the second gen of Docs or BIM 360, is basically to push that model of InfraWorks to the cloud, and then being able to view, measure, do comments, and do some kind of design coordination or review in the cloud. So this is how it will look like in the cloud. Last year it wasn't looking good, but this year apparently they've got it right. You can see all of the objects You can see all of the materials as well. So if I move forward, so there used to be some problems with the texture. Now not anymore. You also have access to those layers. You have access to those materials. You can have an idea about the building itself. Right-click. This is the building created in this date by this designer, etc., etc. Very powerful, very promising, and this is the way forward where we are going. And then we have the different modules. So with the new generation of BIM 360, you will have specific modules. Unfortunately, we don't have time to cover it all. I hope Peter will cover it later, but you will have certain ones that cover, for example, issue management on site, RFIs and submittals, design review, the same one that I showed you, but with added capabilities. These are available, and our customers do have access to them. Specifically this one, I guess it was released last week. I checked it last week. And then we always have Navisworks. So here, basically showing an InfraWorks model. This is the only one I have. It's Civil 3D, could be Revit, could be InfraWorks, bringing them all together to showcase any clashes that might happen on site. There is one very good webinar that I recommend you check it out. It's by, forgot his name, but it's available online, about shared coordinates, how to bring models from Revit, from Civil 3D and others into Navisworks. Which serves the purpose of coordination locally. Instead of pushing things to the cloud, some customers prefer to have it locally. Now for construction planning, as you already know, also within Navisworks, we can simulate in 4D or 5D how the rail station will be built in time. And this is sometimes important for rail owners to check if things will be on time, if you wanna if they want to go to the site and check the progress instead of having the Gantt charts or the BIM model. They just have an exported video and they can check the timeline if there is progress or no progress on site. We can also do some conceptual planning, so we can create different scenarios in InfraWorks or different proposals and then showcase the different stages of the construction on site. Here, this is a well-known project, Millennium Rail, so you can check it on your own later. And we can leverage the BIM model that's created in civil into the construction. So now into the construction part, making use of the automated machine guidance. So this is just a small snapshot about how the BIM model is being used on the equipment to drive the excavator or the grader on site. I guess this is the last part, project experience and visualization. I'm also sharing with you in that folder many videos and things that you can showcase. These are also from Deutsche Bahn. So these are 360 panoramas that were possibly created using Navisworks. You have the QR code. If you have your mobile with a QR code reader, you can just put it in a Google Cardboard or those simple boxes, and you will have a 360 experience of the model. So these are for you to check, and these are relevant to rail because these are rail stations. There is also the power of creating a storyboard, and I'm sure every one of you knows about storyboards. If you have a component road or a design road with 3 to 4 clicks, you can have a very quick understanding about how the rail track will look like. So it's creating all these, it's creating the keyframes and everything in between, and with a click of a button, you drive through all that rail track in seconds. Very powerful, very easy, which can also be exported as a video for sharing or for having it on a flash memory or presentation. This is just a 3ds Max rendering of kind of the same thing of the rail track. So here we're just showcasing the power of Autodesk tools from just not planning, conceptual, detailed design, but also into rendering and experiencing the project. Many other slides about the success stories. I will not show them to you. So these are all videos about some of our customers. So if your customers or prospects ask, tell me about someone who's using Autodesk tools for rail, then you can show them these videos as a proof of point. These are actually the ones I've exported from InfraWorks long time ago. So as you can see, it was called InfraWorks 360. So it's basically one of the, I guess it's the Berlin, yeah. And you can see that this is highly detailed. Also a storyboard from within InfraWorks, another one from within the station going upwards, etc., etc. Also, some figures just to share with our customers and prospects. So what are the expected return in terms of cost, time saving for using BIM? some customer references online, which they can check by themselves, nothing secret. We have some YouTube videos posted by some of our customers, as well as some success stories that are available on the InfraWorks gallery webpage. So these are another one. This is another one, Noor Consult. And these are all videos. So you will really enjoy looking at them and understanding how these owners, operators, or designers went about designing those projects. Deutsche Bahn again, and another one from here. So finally, we come to the document management, and this is, I highly recommend that you all go and attend my colleague Peter Enger's session. It's supposed to be tomorrow between 2:30 and 3:30, where he will touch upon how BIM 360 can be used inside of the construction and infrastructure projects. This is the thing. So we'll come to the bonus. So very quickly, I'm going to show you a video, okay? And I want you to focus, because it's going to ask you to do something. Some of you already seen this video before. So count how many times the players wearing white pass the basketball, okay? So the white players, how many times are they passing the video? Passing the basketball, sorry. So how many think it was 10? By show of hands, was it 10? 16, 15? How many, 20? Okay. The thing is about this video is that it's actually to showcase how our brain works. The correct answer is 15. And I personally got it wrong the last time, although I was very, very focused. And the thing is, we do have selective focus, apparently. So how many of you noticed the gorilla moving? How many? Please, by show. Okay, I would say 30% max. If you look, and 70% of us missed the gorilla that was doing like this, because we have selective focus. And I've seen it in my life. After I've seen this video last week, I've noticed that I'm doing the same thing. I'm missing the gorilla. What I want you to learn from this video is that what you've seen in my presentation is the big picture. Try not to go to customers and show them very detailed features. Give them this whole idea of the BIM workflow and the full portfolio of solutions we have at Autodesk. This is really the key differentiator between us or other competitors in the market. And you can apply it to other things in your life. So this is the thing I would like to leave you with. Now, finally, this is my email address. Feel free to send me any email or questions, but expect a few days to reply back. By this, I will conclude and I will open the floor for questions. Any questions, please? Yeah. Yes. Okay. I think you've seen one of the videos, right? We have some of the gantries on top of the rail track. That's actually not an intelligent object. Could be a parametric object, but what we've done there, we've brought a 3D object as FBX. We've included it as a component, and we used it just for layout purposes and the quantity takeoff. Yeah, I know. Yeah. Yeah, I know. As far as I know, we don't have tools to calculate where these are supposed to be, but you can leverage the tools we have right now to place them at certain intervals, or else use them from the library of InfraWorks to place them at certain locations where you find they're necessary, and then you can use the other tools in InfraWorks to quantify them. As far as I know, do you have any idea about the electrification? Yeah? I think this is what we have at the moment. Yeah. Okay. Do you mean you want to have the quantities of the lines themselves or the structures? The position. Okay. We don't have any analysis tool to do that, to specify where are the correct locations, unfortunately. Any other questions? Okay. So if you're sketching, since you mentioned sketching, inside of InfraWorks, why I highlighted, yeah, detailed design. We have, but I haven't tested all the features inside of Civil, to be honest, for the rail, honestly. So we have the best fit alignments for roads, which I believe if you use the road alignment in Civil and consider it as a rail track alignment, you can leverage all of these tools inside of Civil at the time being. I know you want it perfect, and the development team are working on it. So this is what I can tell you for now. Yeah. Any other questions? I don't think so. I don't think so. Yeah. Yes. Yeah, true. If we have a 3D polyline, so yeah, it will come. Yeah, you have limited capability to modify it. Yeah, yeah, yeah. Yes, yes. It's not new. It's available. So yeah. Yes. Okay. Okay. I've tried it in many regions, and it depends on the region you are in. I would tell you, because I know you're coming from Middle East, it's not that accurate, unfortunately, because the government agencies are not willing to share data. But it's more accurate in Europe than it's in the Middle East. I don't have any clue about Africa or the other regions, to be honest. This is what I can tell you. However, it's just a starting point. So our customers usually have their own data, whether it's terrain or utilities, that they can bring it into a model builder, update certain space or areas, and then move on. Okay. Any other questions? Yeah, please. Yes. You mean the machine? Yes, it's up to 0.3 millimeter. It's yes, yeah. The laser scanner that's on top, it's the state of the art. I'm not marketing, but this is from Leica. So this is the most accurate laser scanner they have right now, and they've mounted it on top of this horizontal device that basically runs through the rail track and capturing all the features. Exactly, kind of, yeah. I've actually provided the link, so you can check it in my presentation. It's in the notes, and they've put there it's 0.3 millimeter. Yes, yeah. The cool thing about it, you can you can specify what surrounding area you want to capture, and to what detail. Yeah. Sorry. Yeah. Yeah. So I believe Frederick will cover that part in his session, right?
No, 12. I think you got it, huh?
Did you guys hear him? Did you guys at the back hear him? I can't hear any yes. And I'm still young, I can hear very well.
All right, there was just a question on the accuracy of the mesh data processing or the mesh data captured on the track. So there's a session tomorrow, I think at 12 o'clock that is dealing with mesh data. Not just the processing within the hardware, but the capturing as well, because it's the co-author or the co-speaker is from Top Gun, so they're into mobile mapping as well, and they can give you some more insight into accuracy and the process of gathering the data. That was it.
Thank you. Any other questions? Yes, please. I was told they're working on it, and they're working actually also on more rail-related styles, more intelligent styles for bridges and tunnels. But I can't promise you because it's not released yet, right? They're working on it already. Yeah. If you have something specific that you would like to see in the product, feel free to send me an email. I'll make sure I'll forward it. I will collect it together into categories, and I'll forward it to the product management team, product development team. Okay? Your comments are really welcome. So we like to hear from you and let them know. Anything more? Okay. Thank you very much, and have a great evening. Thank you.